could we start the stream, please? Thank you. Okay, so the first topic on the agenda today is an update on Fusaka. Do we have Barnabas on the call to give the update?
Yes, we have a pretty nice participation now at about 95%. We have seen a few extra deposits made from their gun team. They are testing their Kotlin validator or their Kotlin CL. We had a few issues, and I have reached out to every single client team about those specific issues. If you are noticing that your validator is not up to head or are having some issues in staying up to head or missing some doc proposals, then please take a look. But other than that, I think we should be pretty good.
Awesome. Were there any notable bugs that were fixed in the last week that we should talk about, bring up?
Nothing really. Like right now, we are investigating some metadata bugs that Teku has. So we have a new tool called eth-das-guardian, and this tool is helping us see metadata fields and status messages of a specific CR client. And this is going to really help us debug smaller problems and figuring out if specific node is costing the columns that they say they would. Still a bit work in progress, but hopefully it will be more ironed out by DevNet 3.
Yeah, and I think the tools also aim to give us a third point of data set whenever there's a discrepancy between two clients, and it'll be integrated into Dora so that it's easier for client devs to also figure out what's going on a network. Yeah, and Justin says there was a small Nimbus issue that was fixed and new consensus specs. Yeah, and the result of verify cell KCG proof patch wasn't being checked properly. Thank you for the update. And on the topic of consensus specs, I also see this one PR from Leo that adds a few new test types. Justin, maybe you could have a look in the CL teams as well if this testing approach makes sense and we can merge it in perhaps.
Yep, we'll review. I'm not sure how I feel about test for test, though. The test and split test. We'll discuss that internally.
Okay, that sounds perfect. And Barnabas, there was also a round of sync tests, right? Were there any findings from that? Are we mostly good? What's going on?
Sync has generally looked pretty okay. We cannot make bigger conclusions right now because we are limited in different aspects. But hopefully by the end of this week, we're gonna be able to do very stable sync tests.
Okay, perfect. And we can just post the sync test repository in case anyone wants to also play around with what's going on. You should be able to check the GitHub actions here. They are triggered once a day, and you should be able to see if your client is passing or failing the sync test for the latest Fusaka DevNet.
Yeah, but for now, please ignore this because we are currently IOPS limited on our GitHub runners. So those invalid tests, they basically just time out after 2 hours. And those are most likely caused by the same bug that the machine doesn't have enough IOPS.
Yeah, right now we can't draw any assumptions on the actual speed. Once we change the infrastructure, then we should be able to also compare speeds of the sync tests. Is Bharat on the call? I saw he had posted a message with an update on med testing.
Yeah, so I'm on the call. Yeah, so in terms of the update to the mev workflows, the first mevboost and mevboost relay, the code is there. I think Justin, thanks for the review. Justin was able to review and it seems good. The code there. So I think mevboost and mevboost relay generally can get it on the devnet. R builder, I was able to hack it around and get it to work locally. So this is like local and Kurtos is local, but it's not like prod ready. Like there are a lot of breaking changes across like the ret and alloy stuff. So I ended up there are some hacks, but it's working. I was able to see like blobs being produced locally and stuff. So yeah, so that's the update. Would love to get that on DevNet too, but one of the problems we're having in the TG chat with Roman is like I think the DevNet Fusaka DevNet 2 branch of Red is it's breaking with EIP 7907. That I'm trying to like work on that to like Roman gave some suggestions. I'm trying to like work across that and I'll put an update on the TG chat. But yeah, that's the current state of like remap workflows. So
Awesome.
basically, some dependency issue with like Red. I'm trying to like I'll try to resolve that.
Okay, that's perfect. Charles, did you want to say something?
No, hello, I just joined.
Yeah. Yeah, okay, that's perfect. In that case, then if the dependency issues are fixed while DevNet 2 is still live, then I do think it's fine to deploy like a fork of something that's unmerged purely to catch bugs earlier so that we have more time to fix them. But if not, it sounds like it would be ready in time for DevNet 3.
Yeah, that's the point.
Okay, perfect. Thank you for that. Continuing on the DevNet topic, we do have a state bloat network that's been working over the weekend. I think there was some minor things found in Nethermind that they're still investigating, but we are aiming to have 2 times the state size of mainnet soon. There is a Telegram group where we're trying to coordinate metrics. So in case there's any EL that it hasn't already been added to the group, then please reach out. There's a list of metrics and type of data that we want to gather, and that's very client specific. So we're going to need your help to get the metrics. The next topic is 45 million gas limit. Lighthouse made a release last week, and I wanted to know what the status is of the other CLs in terms of releases. Okay, then I guess we take that offline. At least the good thing is over the last week, Nimbus also has done its release as well. So we already have Nimbus as well as Lighthouse with their release. And according to the relay APIs that we've been tracking, we have roughly 40-ish, 41% indicating 45 million gas. We have around half indicating 36 million gas and a few which, yeah, we're still figuring out that indicate 30 million gas. So at least over the next days, I think that should sort itself out and we should be fine. And just reading from the chat, I think Prism, Lodestar, as well as Grandine have releases either tomorrow or later this week. Okay, thank you for that. There was one following topic for Fusaka DevNet 3. There's this open PR blob per transaction limit that hasn't been merged yet. Does someone want to give context here and figure out what's missing?
I think PRs are approves are missing. We've discussed this topic many times already on ACDE and ACDC as well. Just for a quick recap, we are to say that we're going to be removing the max blobs per transaction from the blob schedule configuration, and we're going to have it hard-coded for per fork. So no longer going to be part of the BPO, but it's going to be part of the fork.
Okay, I think at the very least we need either Mark or Rahul to approve it as EIP authors, but it would be great if other EL teams can also leave their comments there. Okay, does anyone have anything else to add for the topic? If not, we can move on. Okay. Jochem had a presentation prepared for EIP 7907. Do you want to go, Jochem?
Yes, let me share my screen. Yeah, can you see my screen and also my mouse?
Yes.
Okay, great. All right, I wanted to bring up the the big problem is we want to raise the code size limit. This seems like a trivial problem, but from my side, this is not trivial to solve at all. We are currently introducing EIP 7907, and this is currently scheduled for inclusion for Fusaka. And in this presentation, I'm looking at the version of 8th July 2025, so that's from last week. I just saw that there was a commit merged, but that didn't change a lot. It was just a clarification. What it does is it raises the code size limit from 24 kilobytes to 48 kilobytes, so it doubles it. And it also introduces this metering formula for large code sizes, so you pay more for large code. So that all looks very logical. And this, so if we would raise the code size limit again, then we would also use this formula again if we raise this limit. And how I'm thinking about this EIP currently is also that we are basically using this as a framework for the future to handle or price in these even bigger contracts. And that's maybe also to think about how I currently present this in this presentation. And I want to mainly to raise that point to think about this is because we currently want to introduce this mechanism. And if we would change it later, that would not be nice because then we have this historical code depth. So it would be nice to just do it right on the first try, basically. So this pricing formula, how does it work? The first thing what it does is it introduces a new warm and cold state. So what we currently have is that we have a warm and cold state for every account. Each time that you read a new account, which you have not touched into the current transaction, that's when you move it from the cold state to a warm state. And yeah, so we have a warm and cold account, but we also have warm and cold code now. So if you read code, this will move the code from cold to warm, and the account will already be warm then. So what is currently what you do is you have to pay 2100 gas from cold code to make it warm. And for the big contracts, we use this. We introduce this dynamic formula. This only kicks in if you read bigger contracts than the current limit of 24 kilobytes. If you do that, then you have this formula, and what you essentially do is that for every 32-byte word, which the code is over the original 24 kilobyte limit, is you pay 4 extra gas. And this code size, really, this is actually a problem because this code size is something which you cannot directly read from the Merkle-Patricia tree. And to actually read this from the data structure is what you do is you open the account from the MPT, then you read the code hash. This points to the entire code, and from that you can actually read the code size. So this code size is not part of the account. And if we would use that, so we are not going to do any optimizations in our client's data structure. We have a DOS factor, and this DOS factor is that we can read n times z bytes of data per transaction. This n is the amount of context which we can read per transaction, and this is currently, if we will take the 30 million gas limit, this is about 11,000 contracts, and z is this maximum code size. And just as an illustration, how would you do this? What you do is you have a proxy contract. You call into this contract from, well, I can call it a attack contract. We give us the exact amount of gas which we would have to use to read this contract, but only to read the 24 kilobyte contract, so not the bigger contract. And if we'll do this for bigger contracts, then we can actually pay the static cost, but we cannot pay for the dynamic cost. And the problem here is that if we have to calculate what the dynamic cost is, we need to know the code size, and because we need to know the code size, this means that we have to read, if we do not have this optimization, we have to read the entire code from the Merkle-Patricia tree. And of course, we can get around this by this optimization. But yeah, this is then this is basically an implicit optimization which every client then has to use. And there is also an URL here. I will share the presentation after this, by the way, in the execution spec test repository. So you can also see in practice how this would look. So as I said, the solution for this problem is that, well, we have this code hash to code size and implicit or mandatory lookup cache. Or what would maybe be nicer is to add this code size to the account RLP. And what we'll do then is we could either introduce a new account in the account RLP, or we could do something else like encode in an already existing field, like in the nonce. There are, of course, many variations for this to do this. There are also some other possible problems which I might see, is that if we bump the code size, we also have this bigger witness size, because currently in the code witness, we have to add the entire code to the witness. Another problem which I can see that's more from an economical perspective is that we have to pay for all the code. So if you are calling a contract which is big, then you have to pay this dynamic cost for all the code. And my main concern is that we would end up, well, in the end, that people will still split up the contracts into multiple contracts to avoid that people are paying for these big contracts if they are not using this. So you are actually paying for what you are using. And as an example here, we have this big contract here, and if you use all the code in this big contract in your transaction, then it's fine. We just pay this extra gas. But what if this is, for instance, like an ERC20 contract? We have this transfer method, which is a very small method itself. Then at some point, as in a contract offer, we might realize, okay, I don't want that all my users are going to pay this extra fee for reading all this code. So what I can then do is I can just split up my big contract into smaller contracts. And okay, I have only put one here, but I would put my popular methods in the root contract. And then I would put, well, the unpopular methods into other contracts, such that I am only paying for calling these methods when I actually need those. And this 3000 cost is only for the 48 kilobytes. But what if we would raise this code even further, for instance, to the 256 kilobytes? This would actually cost 30,000 extra gas per call. And yeah, I could imagine that we don't want our users to actually pay this in practice. And that would mean that we would end up splitting up our contracts again. But yes, if we would do that in practice, that's essentially some kind of code merkleization, because in the end, we want to pay for what we use and not that we are paying for everything which we are loading. So just to quickly go over these concerns again. The main concern which I have is its implicit code hash to the code size lookup cache. I don't think we have ever done this before, but I might have missed something, but I don't think we've ever done this before in a network upgrade, that we have this implicit, well, new data structure. Yeah, which we would need. I'm also not sure what would economically happen with this, with having to pay for these big contracts, that you have to pay for all the code which you load. So are we going to see that contracts are actually going to be split up? The other concern is that, well, what if we would change, for instance, in Glamsterdam, our strategy again? Then we still have this code depth that we have changed. We have added this pricing formula, and then we will change it again. Yeah, and also things which we should solve also somewhat short term, like, okay, we know if it's 4 gas per 32 byte word. Is this too much? Is this too cheap? Well, we don't know. We should solve this. And these are, of course, like some small things which we can all fix on the fly. But there are also some things to think about, like, okay, we have this 2100 extra gas to pay if you read the new account, if you read the code. And currently in the specification is you also have to pay this code if you would, for instance, transfer Ethereum to an EOA. So we would call an EOA then we also have to pay this 2100 extra gas, even though we know that this account does not have any code in it. And also in the terms of testing this, I think that testing the current EIP is very big to test, because we have this extra warm/cold category of accounts. So the account is warm and cold, and also the code is warm and cold. And yeah, my final thoughts is I want to stress that I really know that this 24 kilobytes is super small, and we should change it. We should raise it. But we should also think of the side effects, what this might imply and introduce. Yeah, that was my talk. I will share the slides afterwards. Yeah. Any questions? Oh, maybe let's read the chat. Okay, Barnabas is saying, could you not just charge for the worst case scenario? Yeah, Andrea was already saying this will very likely break existing contracts, and we also have to think about this because this is basically like an aggressive way to solve this problem. But this would work in the current context, maybe for 48 kilobytes, that this might break a very small amount of contracts. But what if we would think of expanding this further to, like, for instance, the 256 kilobytes? That would mean that you have to pay upfront the 30,000 gas, and that's of course a lot. So I do not see this happening. Static cost. Yeah, the problem is still that that this will very likely break a lot of contracts.
Dragan, do you want to go?
Jochem, I think we had this discussion already in the Discord.
Yes.
So I don't see those responses that you basically received from both Charles and Ben addressed here. So maybe we can, from the previous slide, maybe we could go through the list that you made and you try to address them.
Sorry,
address all the concerns. Basically all of them. Why?
Yes.
I think most of them are already addressed in the Discord, so for the sake of discussion, it should be good to address them here.
Okay, could you maybe, because I know we discussed this, but I think I was not.
Someone maybe give us a summary of what was discussed on Discord?
Yes,
and
please.
what
Yeah.
maps to these concerns.
For example, implicit code hash, code size, lookup cache. Do you remember what was discussed there? I think clients, it's hard to speak for all of them, but I think they're fine even to, we had discussed this in Berlin, to make this implementation detail. Some clients are going to add this field inside accounts. Some of them are going to add this inside the bytecode they're going to read from. Some of them they're in need of this additional table. But even that lookup on that new table is a lot easier than traversing the tree or anything like that. It's a lot faster. Ben is even proposing to drop that static gas cost that we currently have, and it seems reasonable. Unclear what economically happens. Split contract up. I think Charles and Ben said that there is big incentive to extend, even pay higher gas, because the split of the contract is very hard.
Yeah, I can add a little bit more to that. Basically, yes, you pay for loading the whole contract, but the developer knows this, and so it's a trade-off whether they want to like split some cold paths into like another auxiliary contract. This is actually what I imagined when I drafted EIP 7903, which doesn't touch the runtime code size at all, but it just increases the init code limit. So that in theory, you can have a really, really big creation code and create, I guess, like a single logical contract, which has a lot of physical auxiliary contracts, which hold all the code. But this isn't so easy to implement, and because code might be shared between different parts of the contract. So if you imagine like in ERC20 transfer and transfer from functions, they might share some code internally. And if they're in the same contract, then everything is fine because they just jump to the same internal function. But if the developer or the compiler has to split them across contracts, then the code has to be duplicated. So you don't necessarily get a benefit of like if you split some contract into n different smaller contracts, that the size of each auxiliary contract is 1 over n. There may be a lot of overhead for sharing, and in some pathological cases, like there may be very little benefit to splitting the contract.
So, last 4, code depth. I'm not sure how exactly the end goal of the bytecode loading is going to be. Maybe it's going to be chunking, maybe it's going to be something else. That's basically, there wasn't any discussion in when that's going to happen. It will probably going to be depending on the ZK VM or ZK VMworld, or how we are going to facilitate that a little bit easier. Guillermo?
Yeah, so the way you solve it in ZK VMs is precisely to introduce code chunking, because if you don't, then you have all those prover killers. You can just call Xcode size vary or Xcode hash or whatever. Actually, code hash doesn't matter, but you can call all those like functions that load the entirety of the code, and it will make the provers OM. So I don't think you can go around chunking. So there's no way you cannot do code chunking.
I would agree with that, to be honest. But at this point of time, it's maybe some new novel way will come.
Yeah. How feasible is it to introduce code chunking in the near future? Like, let's say the 6-month, 1-year time frame.
Well, 6 months, it depends on Glamsterdam, the scheduling of Glamsterdam. So if you believe Glamsterdam can come Q1 2026, yeah, I would say it's probably doable. But yeah, like I said, it depends on the timeline. How easy is it to do? Well, there's an EIP that just got resurrected, 2926, of which I happen to be the co-author, and trying to introduce this without all the frills of changing the tree structure, just doing what we learned from Verkle and from binary trees and do it in the MPT. So how realistic is it? I'm not promising 6 months, but yeah, it's still quite realistic.
In general, code chunking requires some kind of tree changes, while this doesn't. So I think code chunking is a better solution, but I think the Glam standard is going to be Bol or some other AIPs. So I'm not sure if we have the space for the chunking.
If I may disagree, code chunking, tree changes has been pretty simple, has been demonstrated, and it's only, unlike the big tree change, it's only 10 gigabytes that need to be copied, so that can be done in a day, if not an hour. I think it's pretty realistic, and I would contend that creating code that is going to be obsolete, because once again, code chunking is, I mean, okay, pending a huge discovery that no one has made so far, it's the only way you're going to allow for ZKVMs. So, yeah, like you will need to do it eventually. I would say might as well do it right the first time.
You will still need code load and that notion of the warm and cold loading. So it's not going to be this AIP, it's going to change how the gas is calculated, but the structure is still going to be there on some way or form.
Absolutely. The gas computation has to match basically what we do in vertical or binary trees like 4762. You will need to charge per load, code load. That's not a big problem. It's just basically the same idea as is present in 7907. I find the numbers in 7507 really low. But I'm happy to change them, and if it makes sense, I'm happy to lower the number from 4762. But once again, this is something that we have understood for over 4 years now, so it's pretty easy to do.
Okay, moving to a couple of conversations from chat, perhaps. For the first one, we're talking about code size data structure being an implementation detail. And one of the asks was A, which clients do need to have it? And B, if they do need to have it, could we agree to have it at Fusaka DevNet 3? And if so, what would the timeline be there? Because if this is going to be a part of the critical path, then we have to get that it will be a delay and we have to figure out what sort of delay we're accepting. Guillaume?
Yeah, it might be an implementation detail, but you will still need to go and build that index somehow. If you put it in the bytecode, if you put it in the account, wherever you put it, you will need to do exactly the same thing that a tree transition does. You will need to go over every code and go and put it there, or you will need to build that index. So I would say, from what I can see, every client will actually need to build that index, because if they don't want to do some kind of process exactly like the tree transition.
Okay, that makes sense. And just surfacing maybe two more related points. One from Marius saying that it's the EIP still feels underexplored or specified, and he doesn't think we should ship a half-baked solution. And Ansgar already has his hand up, so I would let him speak and probably also include his message from chat then.
Yeah, actually, I was wanted to briefly just say, I think, well, mostly agreed with Guillaume. I think actually one thing he said is not quite right, because I don't think there would be the need to populate the code size index for existing contracts. I mean, again, that also would be an implementation detail for clients that for some reason would want to do that. That's fine, but you wouldn't have to do it, right? Because you know that up to the fork boundary, all contracts are below the 24 kilobyte limit, and that's the only information you need for them. You don't need the exact size, you just need that it's below the 24 kilobytes. So basically, like, if you just don't find it in the index, you know it's below 24, and so that's all you need. So you don't need to go and rotate through the existing contract. So just a small thing that makes it actually simpler. Yeah, my comment in chat was specifically like, I would argue that we should make it a hard requirement that before we actually like make the very final call for having 7907 in Fusaka, that we have high quality benchmarks that show that all clients can handle these kind of worst case load patterns at 100 million throughput post with 7907 live. That probably means all of them need to have the index implemented. Of course, if some clients for some reason just are performant enough even without the index to do that, all the better. But basically, I would argue that we should officially say, look, we need to be 100% certain that this will not introduce a new performance bottleneck here. Otherwise, we'll pull it out.
That's fair, but that sounds like it will still take some time before we first have the index implemented and do the benchmarks, right?
Well, yeah, basically the argument is implicitly, if we feel like we can't do that in time, or basically we will only have those numbers, say, 2 months from now, because it takes time to implement the index, and 2 months from now it's too late to pull it back out, then that I would argue that should mean we should just pull it out immediately, because we don't have that databases. If it is realistic, if all the clients say that it is realistic to get those benchmark numbers in time to make the final go no go decision, then I'm personally happy to keep it in for now.
Okay, I do want to maybe mention one thing. This discussion topic is also slated for ACDE. The idea was that Jochem presents all of the information here. We have a first discussion. If there was any information required to be collected over the course of this week, then we that and then present it again at ACDE, and that's where we would potentially make a decision of how we move forward with the EIP. That being said, I think Jochem wanted to say something, and then Ben.
Yeah, I would like to wait the client's opinion on this, because we're talking about if the clients can handle this kind of like new DDoS attacks that could potentially happen. I didn't hear anybody concerned about that other than we should test it. So I would take that opinion in discussion.
Could you repeat that point, please? What DDoS attack do you mean?
Asgard already mentioned, because if we have on 100 million, if all clients can handle AIP 7907 on 100 million, it should be okay, but yeah. Marius, what's your concern?
Like, we still don't really have good reliable numbers on this deal. Like, we have some tests for it, but the problem with the tests is that they, like, potentially even with 24K, you can pull up something like 1.5 gigabytes or something of contracts. With at 100 million, you can 100 million, like 128K contracts, you can pull out like something like 10 or 11 gigabytes. So that is like, it's just a huge amount of data that you need to load from disk in a very short amount of time. And the thing is, the tests that we have, I think for like 45 million gas, they were not run with 100 million gas, and only for like for small, like not the full amount of contracts. And they yeah, like if the like, it's kind of hard to, like, you can create a bunch of interesting edge cases, contracts calling contracts, contracts doing a bunch of jump test analysis, and I just don't see all of this being as easy as people think.
My question is, does this is still concerned without adding this AIP, even with 24K? You will, if you have concern with 48, you will have concern with 24. It's not we are tripling the size in this AIP. That's why we're just doubling it.
Yeah, I do have similar concerns with 24K at 100 million gas.
So it's not exactly the problem with AIP, but with different issue that we need to address.
The effective rate is at 2600 gas per 24 kilobytes is 3.38 gas per word. A recent change was to 4 gas per word for the marginal cost, which I personally think is excessive, but even if so, with this EIP, it's actually more expensive to load a very large contract than multiple small contracts.
Ben, do you want to go? And then Julio?
Yeah, are we 100% certain that there are no contracts above 24 kilobytes that were created before the limits were put in?
Jochem says yes, 100%.
Okay.
Julio?
Yeah, I just wanted to say whether we are still in time to maybe just bump simply the limit without 7907 at this point, or if it's too late.
Yeah, I think that would have to be something we have to present as an option on ACDE.
Yeah.
But it is probably a realistic option.
Yeah. Okay.
Also, just timeline perspective wise, we are in mid-July, and I think if we want to have any hope of having Fusaka done before DevConnect this year, we do need to already start talking about hardening our fork and shipping it instead of figuring out the constraints of the fork. What would be asks from this discussion then? What are data points that we can still collect? It seems like one could be that we benchmark how things look at 100 million. There is still no index, but it could still help us at least get some initial data points as to how clients perform at 100 million. Are there any other asks from this discussion before Thursday? Yeah, Milan?
Yeah, hi. It's not an ask, but more of a question. So I was thinking a few days ago that there's currently two EIPs about limiting the transaction gas limit. And the first one is 30 million, which I think is going into Fusaka. But then there's another one that I saw that further lowers this down to 16 million. And if you have a 16 million gas transaction limit, you actually have an upper bound on like what is the largest contract code that you can deploy, which I don't know, I haven't done the maths, but like it's quite low. Like it's, I don't know, 80, let's say 80 kilobytes. So in my head, there's two things that are competing here. And if we're going to introduce such APs in the future with 16 million transaction gas limit size, then we shouldn't really be discussing like 256 kilobytes code size, because I'm not sure how we're going to deploy these. So kind of, I feel like all these worries are kind of being a bit exaggerated, because I don't see how we would deploy such large contracts if we have such a low transaction gas limit.
Yeah, I'd imagine that in the future, if we do have higher contract limits, we also increase the transaction gas limit, but I don't think we've thought that approach fully through yet. Sorry, just trying to quickly catch up on the chat. Is there any specific message people want to bring back to the call?
I'd just like to follow up on Milan's point that 16 million is in DevNet 3. So it got reduced. So you might want to implement that if you haven't.
Okay, yeah. So I mean, that means that we're even for DevNet 3, we're sort of limited quite a lot in terms of like what is the theoretical max code size that you can deploy. So yeah, I'm not sure why like it's a concern why we're discussing 256 kilobytes when we actually can't really reach that.
Because in the future you might be able to do so.
Even with low transaction gas limit, 60 million.
No, but maybe in the future deploying a contract will be cheaper. Maybe in the future we will remove the transaction gas cost limit. Like, there's no point in specifying that we want to have 128 kilobyte contracts if we will not be able to deploy 128 kilobyte contracts. So at some point, either the cap will go, or we will have some other mechanism of deploying big contracts, or like maybe even just L2s will remove the contract, the transaction cap. But even then, we should be making these test cases and these benchmarks to see is it actually safe even for L2s to have these large contracts?
In general, I would say that this a lot depends on client implementations. So I would like to hear from clients on a few days on ACDE if they think that this is going to be problematic or not. Even
Okay. Yeah, I think
48K.
that can be concrete asks. So clients would need to come to ACDE with a opinion on how difficult it would be to implement the index. The second one would be if they would imagine that it's problematic for larger contract sizes. And the third one is we would need to get benchmarks at 100 million to make sure that we're not bottlenecking on a new front before we even get to 100 million. Yeah, Jochem?
Yeah, one question is, because we need these benchmarks, but what benchmarks do we need specifically? Because I did not get that. Is it jump test? Is it coder reading? Is it what is it?
Well, which of the parts mainly stresses the client the most? Yeah, maybe Tony has an answer. Tony? Or is it a different topic?
No, I have a different one.
Okay, then let's finish this one first. Does any client team have like concrete assumptions of what the DDoS attack would be, or what the attack would be?
Marius, do you have example?
Yes. So what I would like to see is, and I think you already implemented this, is just touching contract. I don't know where you get the 11K number from, because when I computed it, it's like 36K contracts that you can touch at 100
Yeah, sorry,
million.
that's per transaction what I'm talking about, not per block. But you're
Okay.
right. Yeah.
Per transaction. Oh, yeah. So yeah, I was when I did these tests, it was per 100 million transaction or per block. And so I could touch 36K contracts. And then every contract contains a bunch of jump tests, and then jumps to the end of the contract so that it also triggers the jump test analysis or contains randomness, whatever you want to do. And then the other one that I would like to see is contracts that call other contracts 1024 layers deep, and all of them will have to stay in memory, and then it goes back up one step, and then it calls into a second, another 10 like another contract, and then goes back up a step and calls into another contract. So you have this chain of big contracts that call each other. The other stuff is like Xcode size at 100 million without the indices, and then Xcode size at 100 million with an index. And I think those are the main ones that I would like to see.
Yep. Cool. Thank you.
General, code size, code analysis is going to be, because we are spending more gas with the big code loading, it will be better with this AIP. So the attack is mostly concerned about older, current, present bytecode. And even with AIP 7907, we have additional cost, static cost for loading the code. So we will reduce the attack vector with this AIP if this cost is here.
One other thing is like calling a contract and then reverting because you don't have the the required gas to do the to pay for loading the contracts. That would trigger this edge case where you also need the index for it. Right?
Okay, I'd like to stop the 7907 discussion here and then maybe to Tony.
Yeah, just regarding the transaction gas limit 7825. I put it onto so last week after the testing call, after we lowered it from 30 million to 16 million, 60.7 million, I put it onto the ACDE agenda this week. So I think we should discuss it there again.
Yeah, perfect. Thank you. And Barnabas, do you have some update on DevNet 3 planning? What else is left over before we launch DevNet 3 and what's the timeline there?
So this is probably one of the main blockers for DevNet 3, and I'm not sure how clients are with implementing all the different repricing EIPs. The spec sheet should be updated, and I think we only have 3 more open PRs that needs to be merged before we can launch.
Okay, and I think one of them was the PR Raoul merged during the call, right?
Oh, that has been merged now? So the blob per transaction limit has been merged. So then there's one more for the execution API, and the builder spec would also probably want, like, I would like to get that also merged in.
Okay, that sounds good. Then I guess the after we have a decision on 7907 on ACDE on Thursday, we should have a timeline for DevNet 3 as well. Yeah, we can discuss the execution API EIP. It's the one from Raoul about partial responses. Does someone have a status update on how this is going?
Yeah, so this was discussed in ACDC last week. There was a bunch of considerations there, but overall the sentiment was we should just push and do it now. And there's been one approval, and we're just waiting for more EL and CL devs to chime in and just approve if they still see it fit before we go ahead and merge. And I think the idea is to freeze the execution API spec soon. So this would be stopping it from that.
Okay, perfect. So let's try and get this EIP as well merged in before Thursday, and I think we should be very close to then figuring out a timeline for DevNet 3. The Sunnyside Labs team wanted to give an update on their latest testing. Do you want to go?
Yeah, sure. Thank you. Let me just post the link to the chat. Yeah, so briefly just summarizing what we have done. So we've ran every single CL devnets and EL devnets except for Nimbus EL with 8 validators for full nodes this time, and then every single CL devnets were able to reach up to more than 60 blobs per block. And Nimbus, which previously was at 9 blobs during Berlin, was able to reach up to 40 or more. We also could confirm that all the tested EL clients supported more than 72 blobs per block. And we also then tested whether clients can sustain high blob throughputs, and we found with a 128 node mixed combinations at 60 blobs per block for every block on average, we could maintain stable DevNet for 48 hours. We then limited network bandwidth at 30 megabits per second. Which we found on single CL DevNets, we were able to achieve around 60 blobs per block. And with the 128 node DevNet, we were able to achieve around 45 blobs. So, and then we looked at like what kind of things that limited the blob throughput on such bandwidth caps. And we found short bursts in network traffics kind of bounded the network usage, the blob throughput limit. And other than that, there were minor findings in the networking resource usage. We've also done Genesis sync test, which we were able to confirm that all the CLs and ELs passed, except for Geth, but the fix for Geth is up in the review. So I guess like we are at pretty good stage at the moment, and as Paritosh said, hardening the CLs and ELs for Fusaka will be quite important next steps by testing out edge cases and continue doing stress testing and interrupt testing.
Yeah, I think so Barnabas had a couple of test scenarios that he wanted to see done. I think he sent you guys a list, as well as including transactions in the DevNets, right? Spammer should have a bunch of scenarios, and I think we'd like to see a version of this benchmark result also with the default spammer transactions going in.
Yeah, I think Marius and Raul also commented about that, so we should definitely add that to the next DevNets.
Perfect.
Yeah, so just to chime in here, there's a bunch of things that this is great testing, and it's great that we have you to do it. Just to kind of like make it more realistic, there's a bunch of things here that I think we'll need to do. We'll need to constrain the bandwidth, the upside and the downside of the bandwidth, and differently. We'll need to have different types of nodes that follow the I think it's EIP 7870 specification. So we'll need to have different which mandate different bandwidth requirements depending on the node profile. So we'll need to add that. I think we'd benefit as well from backfill tests that we do here. We do want to create blocks, for example, that are competing with blobs during propagation, and specifically blocks that are saturating the available blocks, like that are saturating gas and creating pathologically large blocks to disseminate after compressed, right? Because this is the object of dissemination. So things like that are things that I think will continue giving us way more signal. And I think we also want to apply different latency distributions here, and we want to definitely capture the latency distributions that we've applied for each of these DevNets. Another thing that we'll want to do, I think, is we'll want to artificially constrain the gossip sub parameters, because these are small test nets. These are 50 nodes, which means that there are very few hops if we're using the gossip sub parameters of mainnet. So we'll want to artificially constrain those so that we're replicating the number of hops and kind of like the travel time that messages will have to do in mainnet to get better signal. So yeah, I'm writing all of these things up. I'll send you some feedback. And yeah, Barnabas, happy to integrate any other tests you want done here as feedback for Sunny Satellite Stream.
Perfect. Thank you guys so much. Is there any other topic we want to talk about? There's a point from Francesco about skewing bandwidth findings. Maybe we take that one to Discord since we're at time. And thank you everyone for joining. Hope you have a nice day.
Thank you. Bye-bye.
Thank you.
Yeah.
Thank you. Bye-bye.